Hello everyone, welcome to this webinar, exciting new features in nRF9160 modem firmware version 1.3.0. So this is a Nordic tech webinar and I am Martin Lesund. I'm a technical marketing manager for Cellular IoT here at Nordic Semiconductor. Earlier I've been working in the tech support group around 3 years and also been focusing mostly about Cellular IoT and nRF9160 there as well. Just some practicalities before we begin. This webinar will last around 45 minutes and we are going to have a Q&A at the end. So questions are of course encouraged. Please type your questions in the top of the right sidebar marked with Ask a Question. All questions are anonymous and try to keep them relevant to the topic. As I said, we are going to answer them towards the end. The chat is not anonymous, however, so you should not use those for questions. And if you have any questions after this webinar, please go to DevZone and post your questions there. A recording of the webinar will be available together with the slides at webinars.nordicsemi.com. And the agenda for today is important note before use, and then we're going to look into the new power optimization features. Then we're going to look at the cellular positioning and GPS features, and 3GPP release 14 features and other new useful features. And Q&A at the end. Important note before use, the modem firmware 1.3.0 is targeted nRF9160 system in package revision 2. This is the production version of revision 2 and is marked with the B1 on the system in package itself. You can see that on a figure on the right hand side, or you can check this by an AT command. 80% hardware version is this command. And of course, if you have a Nordic nRF9160 system in package revision 1, this is marked with B0. You could use the modem firmware 1.3.0, but only for testing and development, not for production use. And if you have an older nRF9160 revision 1 engineering sample, these are marked with E2, X and Y. For example, E218, these system in packages will not boot if you run modem firmware 1.3.0. That means if you have an older kit, either a development kit or a Thingy91 with the version 090, below 090, you cannot run modem firmware 1.3.0. So then you need to upgrade if you want to test this new modem firmware. These are found on the version is found on the stickers, either on the back side of the DK or on the front side of the Thingy91 on the sticker. So both these figures here with the versions, they need to be updated. And we also have a downgrade limitation with this modem firmware. So we do not recommend to downgrade from 1.3.0 to either 1.2x or 1.1x. This is because there is a modem file system that's a bit different, so it's not compatible with older modem firmware. That means if you downgrade, you can cause file system issues like losing certificates and keys. So we do not recommend this. So if you're going to develop using an older modem firmware and modem firmware 1.3.0, we recommend that you have a dedicated hardware running with the specific versions, so you can develop in parallel. So now over to the nice new features. First off, we are going to have a target that all carriers is under this one modem firmware. So before you knew you needed a specific modem firmware version depending on which carrier you're going to certify against. With this new one, you only have the one modem firmware to actually care about. So this is what we target with version 1.3.0. So this makes it much easier for customers to just select the correct modem firmware version. And now just a quick recap of the different LTE modes that the modem can be in. You have RRC connected mode, RRC idle mode, and power saving mode. So connected mode is where you send and receive data over the network, you stay synchronized with the network, and you use a lot of current in this state. So the next mode is RRC idle mode. This is where you just listen to the network in intervals, so you just turn on the receiver side in between dedicated intervals. You can also increase those by increasing the EDRX intervals, for example. And in this state you use medium to low power consumption. And the last but not least is the power saving mode. This is where the modem sleeps but is still registered to the network. So that means when you wake up from PSM you don't need to reattach with the network. And in this state you use ultra low power consumption, around 2.7 microamperes in average. So first to the power optimization features. So this first feature here is very specified for first LTE search optimizations. So this means that you can speed up the network selection when moving to a new area, for example, or first time deployment of the nRF9160 device. You have now a new 80 command, 80% country data. In this command you can store many parameters and set up a prioritized list with mobile country code, bands, radio frequency, channel number, LTE-M, NB-IoT in this list. So the modem will go through this list for when it's going to search for the first time. And if it do not find anything in this list, it will go over to this normal full search that we know from before. So this will improve the first search when you know where the device is going to be shipped. And also another new nice feature which is also related to searching for networks. It includes this modem domain events. So you now get notified by different modem domain events such as search status 1, search status 2, reset loop, mobile equipment overheated, and mobile equipment battery low. So these first two notifications are the ones I want to highlight. Search status 1 is a light search, so this means when the modem has finished its most intelligent guesses to select a network, it will notify the application search status 1. And from this, the application can choose to turn the modem off to save current consumption. So this feature is very helpful for very constrained devices that needs to use as little power as possible. And if you are in some bad conditions and you do not want to go into this heavy search that can use a lot of time and power, you can just turn off the modem after this light search and do a new search later on. If, for example, you have a device that's moving and you want the device to move to an area that's better suited for searching and coverage. So this next feature here is very useful after you're done your searches and connected to the network and you need to actually send data. So now you can actually evaluate the power consumption the device is going to use before sending any data. So this is very useful in devices that needs to save power, and you need to check how much power you are going to send, how much power you're going to use when you're sending the data. So this new feature actually performs a short measurement on the receiver channel and analyze the radio environment through the downlink on the cell. And through this short measurement, it will estimate the power consumption it's going to use when it's going to send data. So you get the response either excellent, good, normal, poor, or this bad category from the modem and based on this you can choose to go ahead and send the data or wait until you get better reception, for example. So if you are in bad conditions, it will mean that you will use a lot of current sending data. You can also assume that you get some repetitions, maybe some packet loss, and therefore you can choose to only send data when you are in excellent, good, and for example normal conditions. And also this new feature includes that you can receive all the raw parameters to the application side, so the radio link quality, RSRP, RSRQ, SNR, CE levels, TX power, repetitions, path loss, +++. So you get a lot of parameters received from the modem, so you can do some clever decisions yourself on the application side if you want to, based on these parameters. This is also supported by the AT command, which is introduced here. So just a side note, all the new AT commands that's introduced in this modem firmware 1.3.0 has been documented and is updated in our AT reference manual on InfoCenter. It's AT reference manual version 1.7. And this is also a new feature in the modem firmware. It's called non-IP data delivery, or NID for short. This essentially means that you remove the IP headers from the payload, and this is a NB-IoT only feature. This means that you do not have to have the radio on to send the additional headers, and you just send the raw data instead. So this will save power. And now there's two possible methods to do this. The mobile network operator provides the services for you, or the mobile network operator provides something called as SGI tunnel to an external solution, for example a device manufacturer's own solution. Or the other method is that you have something called service capability exposure function, SCEF for short, that can provide additional services via REST APIs for IoT applications. So the SCEF solution is more or less a standardized REST API towards the mobile network operator, and you can by using this method you can actually get a lot of details about your device. For example, timing info, the PSM sleep, how long it's going to stay in PSM sleep, and through this information you can actually synchronize your application service to actually send data when the device is awake, for example. This is very important for networks that do not buffer data. So some networks do not buffer data if you're trying to send any data to a device that's sleeping. And you can test this now by configuring the non-IP PDN connection via an AT command, and then you use the normal raw socket interface from nRF Connect SDK and bind the raw socket to the non-IP PDN connection. And here is another new nice feature, modem sleep notifications. So this feature has been highly requested, and we have implemented this based on customer feedback and what they need. So now you can get information about all the inactivity periods in the modem radio usage, and also get a pre-warning at the desired time before the radio activity happens. So you can use this feature to actually synchronize with external sensors, for example, when to read and send data. And you can also use this information to turn on, for example, specific hardware components before the modem is turning on for specified applications. And some things that you do not know about, for example, operator-specific requests that wakes up the device, SIM card requests can also be a thing. And then you can get this notification before the modem wakes up, and you can do the necessary things before this happens. This is supported by the AT command X modem sleep. So you can check many different modes when the modem is off, for example PSM, EDRX, RF inactivity, when you are in limited service, flight mode, etc. So this is very nice to optimize the power efficiency for devices that needs to synchronize and depend on the modem radio activity and the inactivity. And the next feature is also very nice. It's specific for the periodic tracking area update notification. So this is something that's specific for network to network, how often you're going to do this tracking area update. Some networks, for example, require 1 hour intervals, and some requires a lot longer. So this notification feature here tells you just before you're going to do this tracking area update, so you can synchronize external devices to turn on, for example, before this tracking area update, or that you, for example, send data included with this periodic tracking update to save a little bit of power to send data while the radio is on. And an important note here is that you can avoid the periodic tracking area update completely if you just send data before this tracking area update. And this feature is also supported by this new AT command XT3412. More details about all these features can be looked up into this AT reference manual. And now over to just some general improvements on the modem side. So we have done a lot of work to improve the searching algorithm for better efficiency. So now the modem will do some clever decision based on different parameters that we have included and historical data. So it should do a quicker network search and also find the network faster and save more power than before. And also we have improved the behavior when a device moves between countries. And also we have improved the cell selection and reselection. This means, for example, the connections will more likely initiate on better cells compared to before. And connections should be established faster and regaining lost connection are improved compared to before. And another very nice feature is that we have improved the paging reception. So the modem will stop monitoring the page reception during occasion where after decoding the first number of repetitions on a paging channel. So essentially this means some networks have implementations where it uses 256 repetitions on a paging channel. And before, the modem needed to stay on all the time to receive every repetition, but now it can decode just a few first number of repetitions and then turn off after that. So this will save a lot of current in those scenarios. And also we have now dual search and automatic LTE system selection support. This is documented in the ATX system mode command. So now we can actually search both for LTE-M and NB-IoT concurrently, and this is very useful to if you are in areas where you have support for both LTE-M and NB-IoT. So before you actually could do similar behavior, but you needed to search, for example, on LTE first, LTE-M first, and then if you did not find anything, you get a message to that application, and the application needed to turn off the modem, switch the mode, and turn on again. Now you save a lot of current by just doing everything in the modem side. And now over to the new cellular positioning and GPS features and improved performance. So this first feature is called neighbor cell measurements. So this is supported by a new AT command. And this AT command provides the current and the neighbor cell information. this information can be used with LTE location services, and these location services will give back the location of the device. This is very useful for asset tracking and also indoor tracking, and this is also very low power because it uses the LTE connection compared to GPS, for example. GPS uses more power than this. However, the accuracy will of course not be as good as GPS, so it also depends on how many cells that's around your device. But we have support for up to 17 neighbor cells in response, and max 6 from one frequency. And if the network supports this, you also get the inter-frequency neighbors included if that's configured by the network. So we can see that there are some different networks that support different things, so some features need to be tested in field to make sure that it's working okay. But here is a demonstration on how this can look like. This is a car driving around with the Thingy:91. It drives around for around 17 minutes, running an application on the Thingy:91, reporting the neighbor cell measurements each minute, and sends this out to a LTE location service, and you get back these location areas here for each point. And you can actually see the rings that the accuracy is different depending on how many neighbor cells are in the area. So some places you can see a very highly accurate location with very small rings, and sometimes you get a big ring with low accuracy. However, you can clearly see where the device is traveling on a main road. So if you have an application that going to use as little as possible current, you could use this feature to get the location, and if you need more accurate location, you can, for example, switch to GPS when you get closer to the area that you're going to deliver the package, for example. So a combination of LTE services and GPS is a very nice thing to do for asset tracking, for example. And talking about GPS, we have new features, and we have support for QZSS, quasi-zenith satellite system. This is actually 4 additional satellites that can be used for GPS satellites. These satellites are located around the APAC area. This was a satellite system developed by and targeted for Japan, but it's very useful in large parts of Asia, Australia, and Oceania. So if you have a device in this area, you should expect to get a quicker GPS fix since you have more satellites to connect to. And now we also have support for 1 pulse per second on the coax pin. So you get a time-accurate programmable pulse train, either an interval between 1 to 1800 seconds or a single pulse. So you have a programmable trade-off of accuracy versus power consumption with this feature. And also we have a new feature for optimized tracking modes. So now we have 4 modes you can choose between to optimize the algorithms in the GPS side based on your application. So you can select the general mode if you don't have any specific applications like the other modes. So the other modes are stationary, pedestrian, and vehicular. So if you have a device that's stationary, you can select that mode to the GPS, and it should behave differently and optimized based on this selection. And this supports continuous tracking mode only. We also have this new 3 satellites first fixed and reacquisition feature for several modes. Before we had this only usable in periodic tracking mode, but now it supports all start modes excluding cold start. So this is activated by selecting relaxed accuracy mode. This is also known as low accuracy, so you can select this feature here, and you should get a faster GPS fix but lower accuracy. But this will also save current consumption because you do not need to have the GPS on for a long time. And now over to some GPS performance improvements, general. So we have improved the speed up of the satellite search and processing during cold start acquisition. We're going to look at the graph on the next slide showcasing this. This has also been improved on the speed up of satellite search and processing during hot, warm and reacquisition. For example, GPS hot start in modem firmware 1.2.x versus modem firmware 1.3.0, you can see in severe conditions we have 11 seconds for this time in the old modem firmware, but now it's around 6 seconds with the new one. And you have an improvement around 54%. So to improve the speed up of the GPS in different scenarios have very huge advantages for the power consumption, because GPS can use a lot of current, and to have the GPS on as short as possible is saving a lot of current. And also we have improved the assisted GPS start speed up. So we have an average 3.6 time to first fix reduction improvement in open sky conditions. So for those who do not know, assisted GPS is where you download the ephemeris and almanac data from the LTE network. And now also we have support for downloading the time of week, and that's why we see this improvement as well. So before you needed to download the time of week from each single satellite, and that took a lot of time, because downloading stuff from a satellite can be time consuming because it has a very low throughput. So this is improved with this feature, and we also improved that if you're not using assisted GPS, you only need one satellite to download this time of week parameter. So that's a very good improvement. And the next feature here is that the digital signal processing optimization has been done in the GPS. And this is specific for the continuous tracking mode, that we have actually managed to reduce the current consumption for around 2 milliamperes in this mode. So that's a very big improvement. And this graph is showcasing the satellite search during cold start acquisition, and the figure here describes the expected time to first fix in different coverage scenarios. So the more you go to the right, the better the coverage, and you can see that for the modem firmware 1.3.0 we get lower time to first fix in these scenarios. And now over to the 3GPP release 14 specific features. So first, just some important notes that the release 14 features are disabled by default. These can easily be enabled by an AT command, rel 14 feet, and by this AT command you can select specific release 14 features to be turned on based on what you need. The reason why we have done this is because some carriers do not like the combination by release 13 baseline with cherry-picked release 14 features. So if you're going to certify against a carrier with release 14 features, you need to talk to them if they can support it like this, or you can talk to Nordic for more information and help with this. But over to the nice new release 14 features here that's very useful in different scenarios. The first one is this MAC inactivity monitoring. So this is basically a safety net if the networks does not provide the expected RRC release event. So after you have sent your data, you go into a RRC inactivity timer. This timer is different from network to network. And after this timer has gone through, you will get an RRC release from the network. However, if for some reason you do not get this RRC release from the network, you can get stuck, and this MAC inactivity timer will take care of turning off the modem when this happens. So this is handled automatically by the modem to avoid getting stuck in RC connected mode. So this timer is slightly longer than this RC inactivity timer. And this next one is also related to RC inactivity timer. And this is Access Stratum Release Assistant Indication Support. So this new feature actually makes it possible to skip the network-dependent RRC inactivity timer. So you can tell the network that after you have sent your data, you have nothing more to send or receive. So you can ask the network to put the device into the next mode. So you don't need to stay up for this RRC inactivity timer. This is very, very helpful for networks that has long RRC inactivity timer, for example. This timer can be around 4 seconds in some networks. Other networks can be 15 seconds. And this is actually a timer that you need to go through each time you are in connected mode and send or receive data. So this is something that we had in NB-IoT in older modem firmwares, but now we have support for this in LTE-M as well. So this is also supported by this new AT command. And just to showcase how much you actually can save by just using this new feature. So in this example, you have a device, nRF9160, that sends a UDP packet each 30 minutes, around 1 kilobytes. And the rest of the time it goes into power saving mode. And in the conclusion here, or the result we are seeing is that by just using the AES release assistant indication, you see a 50% improvement in the battery life. So on the left hand side we see where the network gives you an RC inactivity timer around 11 seconds. And in this scenario we would have a total average current around 72.5 microamps. However, using the AES array support, you get around 37 microamps in total average current. So just looking at the battery life, you get 2 years and 1 month of battery life not using the feature, but 4 years and 3 months of battery life using this new feature. And this is based on a 1400 milliamperes battery. And the estimates are based on our online power profiler, so you can actually do this testing yourself as well. So by just enabling this feature, you can double your battery life in some scenarios. So this is very, very important and a good improvement. And now over to another nice feature or features that improves the data rates for NB2. So this is a NB-IoT only feature. So from before we had one HARC process, but now we have support for dual HARC, and also we have support for max transport block size support. And both these features increases the maximum downlink and uplink data rates in good signal conditions. So in this matrix we actually compare the NB1 and NB2, so the release 13 in the modem firmware, the older modem firmware, and NB2 in our new modem firmware. on different parameters here. So for example, the uplink, the max throughput, has been improved by 271%. And the uplink max transport block size in narrowband physical uplink shared channel has been improved by 256%. And also the downlink has gotten a very huge improvement. The max throughput has been improved by 466%. And also the downlink max transport block size change on narrowband physical downlink shared channel has been improved by 373%. So now we can see that the data rates are a lot improved for NB2. So this is very nice features for NB-IoT specific applications, for example. So now we can send more data and higher throughput. That means that you don't have to have the radio on as long as before, for example, to send the same amount of data. And now at the end, just some other features that was not categorized. And this first one here is key generation and key injection. So before you needed to actually use some third-party applications on your computer, for example, to generate keys. But now you have support for this in the modem, where you can actually generate the keys by an AT command. So you can generate a client private key and certificate signing request, also client private key and public key, and also device endorsement key pair. So these are keys that can be used for different scenarios. You can, for example, use the client device certificate and corresponding private key used for TLS client credentials, which is very useful. And also you have support for key injections, which means that you can inject encrypted provisioning messages directly to the modem. And also we have support for generating JSON web tokens by this new AT command. So many new nice features with regards to keys. And this is the next feature that's very useful. You can get a RX-TX indication on a specific coax 2 pin. So you can actually configure a coax 2 pin to toggle right before the RF usage is going to happen. So right before you're going to have any transmissions or reception on the modem, you can actually get a signal out from this pin. And this pin can be very accurate. You can select between 3 different anticipation timings. The pin can be toggled, for example, 1 millisecond before it happens, 400 microseconds before it happens, or around 50 to 100 microseconds before that happens. So this is very useful to synchronize, for example, sensitive sensors or other radios that you have on a device that cannot be run at the same time as the TX or RX is running on the modem. This is supported by this new AT command as well. And also some new AT commands that have not yet been mentioned is this ATX factory reset, which basically resets the modem parameters to factory settings, and also this new request attestation token, which is just authentication of the Nordic device. It will give back an answer which will authenticate that this is a real nRF9160 system in package. And we also have updated different AT commands, and for the full list I really encourage you to check out the updated AT reference manual for more details. So now we have gone through a high level of all the new features in modem firmware 1.3.0, and for more details you should check out the AT command reference manual, or if you have any questions around the features, please go to DevZone and ask questions there. And if you want to register for any upcoming Nordic Tech webinars,